Hey young man, Mr. Maldonado here. Alright, so we're going to be talking about the rock cycle. Now one thing that I want to point out is that it is a cycle. Meaning that if you have a sedimentary rock and then it turns into a metamorphic rock, it doesn't have to stay metamorphic for the rest of its lifetime. It can become igneous. It can go back to sedimentary. It can go back to sedimentary, and then from that sedimentary, it jumps over to igneous. So it's a cycle. They can keep going back and forth from one type of rock to another. Alright, so before we actually look at the three different types of rocks, we need to figure out exactly what kind of physical processes happen on the Earth that start to affect or impact the rock cycle. So the first one we have here is known as weathering. Now, you should know by this point exactly what weathering is, or if you don't remember, it's okay because we're going to go over it right now. Alright, so weathering is the breaking apart of things found on Earth caused by wind, water, ice, or gravity. Alright, so I have a strategy that I like to use to remember exactly what weathering does. So please go ahead and write this down. I like to use weathering, breaking. So these two words have something in common. Can you tell what they have in common? Exactly. They both end in ing. So imagine, you're grabbing a stick. For example, hold out your hands right now. Pretend you're grabbing a stick and pretend you're breaking it. And as you're breaking it, say weathering, breaking, weathering, breaking. So you remember that. So things on Earth, such as landforms, when they break apart by either wind, water, ice, or gravity, gravity pushing down on something or pulling something down so it breaks, all right, that's the process of weathering. Once something is broken apart, all right, by weathering, then we can go to the next step. Here we have erosion. Erosion is the movement of things on Earth caused by wind, water, ice, or gravity. So once again, in order to remember erosion, I have a strategy for this one as well. For this one, I like to use erosion, motion. So what do these two words have in common? Great job. They both end in ion. So we started with weathering, breaking. Remember, you're grabbing the pencil or the stick, weathering, breaking. Now for erosion motion, you're going to kind of start moving your body kind of like in a circular motion. You're moving around, all right? So you start with weathering, breaking. Once the pieces are broken apart, so for example, you have a cliff, and then the gravity, kind of breaks part of that cliff off to the ground. Well, from there, it can shatter into a bunch of little pieces, still through weathering. And then after that, maybe the wind will blow those pieces away. It'll move them somewhere else. That's erosion. Now, when erosion finally comes to an end, once it reaches a spot where those pieces are going to end up, that's when we have the last part. Here we have deposition. So deposition is the deposit of things moved on Earth caused again by wind, water, ice, or gravity. So think of your bank account when you think of the word deposit. If you deposit money into your bank account, is it going to get bigger or smaller? Exactly, it's going to get bigger. So for example, if you have sand being moved by wind, so it's moved, it's through erosion, and then it gets deposited into a certain spot, is that area of the beach going to increase in size or decrease? Great job, it's going to increase in size. So to help you remember what happens with deposition, that things are dropped off somewhere, I like to use a strategy, deposition down. What do these two words have in common? Great job. They both start with a D and end with the letter N. So now, if we go back to weathering, pretend you're holding that stick, you say weathering, breaking, then erosion, motion, you're kind of moving yourself around, erosion, motion, and then with your hands, make a, kind of like if you're patting something down, so deposition down. Alright, so that's the last step. So these are the three physical processes that occur that allow the rock cycle to take place. Alright, so now we can start looking at the very first type of rock. Here we have what we call the sedimentary rock. Alright, so sedimentary rocks are formed when sediments or pieces of other rocks or dead animals and plants are deposited, and we talked about deposition already. Now this is very important, they're deposited in layers. Okay, so before we finish this definition, let's look at the picture that we have here. When they're deposited in layers, if you look very carefully, you can see all the different layers that you have here of different sediment that was left over so much time. So when they're deposited in layers, they're then compacted, meaning that they're going to be crushed together. All right, so they're all compacted, one on top of the other, they're crushed together. And finally, they're cemented. Okay, cemented is the binding of the sediments, and what I like to use is cemented. It's kind of like a glue. All right, so that's what happens. So these sediments, these pieces, they're deposited in layers, compacted or crushed together, and cemented. They're glued together, and now they form what we know as a sedimentary rock. Let's move on to the next type of rock. Next, we have our metamorphic rock. All right, so this is a rock that is formed deep underground, where, this is very important, that's why it's in bold, heat and pressure cause existing rocks to be changed in both mineral composition, so this means it changes what it's made of, and also in its structural characteristics or how it looks. So this rock that you see right here could have been the rock we saw on the previous page, that sedimentary rock. But then when it's deep underground, all the heat that's there and under the crust, so under the surface of the earth, there is a lot of heat. All right, so there's a lot of heat, and because of gravity and different things, it's being pushed down. So there's a lot of pressure there. So it ends up changing what it looks like. So this could have actually been that rock before, because you can still see some of the layers there, but then it's changed. All right, it doesn't look the same anymore. It looks different. So that's a metamorphic rock. Now we can go to the last type of rock. All right, so right here we have an igneous rock. So an igneous rock is formed when lava or magma cools and solidifies. So when it cools down, what happens to the temperature? Great job. When it cools down, the temperature decreases. And when it solidifies, it becomes hard. So, before we move on with this definition, let's look at the two different rocks we have in this picture, because these igneous rocks, all right, they can happen in two different spots. So the first one that we're going to look at is this one right here. This one is granite. All right, so granite is considered intrusive. Intrusive, if you look at the IN, it's inside. All right, so this happens inside the volcano. All right, so when it happens inside of the volcano, that's where we have magma still. That's what it's called. It's magma. Because it's still hot underground, all right, it can cool down and the temperature decreases, but it takes a while. So right here, the magma is going to cool slowly. So when it cools slowly, you have this right here where you see all these little types of crystals in there. You can still see these crystals. They're rather large. All right? So that's an intrusive rock. It happens inside of the volcano still. Then we have over here, this one is called obsidian. Now obsidian is known as extrusive. So I like to use the EX of extrusive, kind of like exit. So it's when it's exiting the volcano, so it's outside of the volcano. All right? So when the magma reaches outside now, the volcano's erupted and now it comes out, that is known as lava. So think about it. The temperature here on the surface where we are, is it hotter or cooler than underground? Great job. It's cooler here. So because it's cooler, the lava cools quickly. So when the lava cools quickly, it doesn't have time to form some of those crystals, and that's when you get that smooth surface that you see on the obsidian rock. Now, before we move on, I have a little strategy that I like to use for an igneous rock, so kind of something that sort of helps us remember where the igneous rock is formed, that it deals with the volcanoes, the magma and the lava. When I write the word igneous, so make sure you write down the word igneous too, like I am. From the eye of igneous, I like to kind of shoot out little things like this, kind of like the volcano when it's erupting and the fire's coming out and the lava and all that stuff or whatever. So that's what I do with the eye of igneous to help me remember that this is the one that deals with volcanoes. So now let's wrap it up and kind of review the whole thing and see how you do. So go ahead and write this chart on a piece of paper. You can write on the back of the graphic organizer with the vocabulary words I gave you. Once you're done writing this chart, go ahead and continue playing the video. Alright, so right here, this is a T-chart. On the left side we have the formation. I have the 3 different types of formation out of order, not in the same order as we saw it in the video. And on the right side it's rock type, but it's blank right now. That's what you're going to fill in. You're going to look at the different types of rocks and how they're made, and based on what I put here as formation, figure out what type of rock is being formed there. So let's look at the first one. Cooling lava or magma. So lava and magma, what does it deal with? Great job. It deals with our volcanoes. So which one did I tell you to kind of draw like a little volcano, with the little things coming out of it? Great job. This one right here is your igneous rock. Alright, great job. Number 2, rocks formed with deposition, compaction, meaning crushed together, and cementation, or being glued together. Great job. Right here you have your sedimentary rocks. And lastly, number 3, rocks being formed with a lot of heat, so it has to happen underground, and a lot of pressure, a lot of pushing down and stuff. Which one is that one? That's deep, deep, deep underground with a lot of heat. Great job. This one you have your metamorphic rock, where it changes completely what it's made of and what it looks like. Alright, so thanks for watching, young men.